Last episode, we went over a basic introduction to dependency injection and other techniques to allow you to decouple your objects from hard-coded dependencies, or to make them reusable in general. While manual dependency injection on its own is often a great path to decoupling and suited for most situations, there are times when it requires a lot of extra work. It also requires some extra thought and placement consideration. It can lead you down a long and twisted rabbit hole if you're not careful, and sometimes it's nearly unavoidable. In lieu of this, dependency injection containers came about. In short, you're inverting control of the dependency resolution and object building to a specific object. You may have already used one and not even been aware of it. The Laravel app object is actually an instance of the Illuminate IOC container. Symfony also has a DI container, Pimple is a popular DI library, and Zen Framework has a few from what I've heard. While I recommend using one of these mentioned if you were building a production application, the Laravel IOC being my favorite, we're going to build our own and see how things work. As a heads up, we'll be using closures to resolve our dependencies for us. We could use other means, but this way is simple and easy to follow in my opinion. It's also quite flexible. This episode will pick up right where we left off last time. Let's start off in our new file named ioc.php. Inside of here, we're going to create a class with a matching name. And then we'll keep it nice and simple to start with by creating only one static property named resolvers. And we're going to use this to contain all of our registered resolvers. And then we're going to make two static methods, register, which will accept the name for the dependency and a resolver closure, and then make, which will take the name of a registered resolver and return us an instance of that object. We don't necessarily need this interface to be static, but for the sake of keeping this globally available, I'm just going to keep it as such. Now let's fill in our register method with static, resolvers, name, equals resolver. That's it. Probably much simpler than you were expecting if you hadn't seen a basic DI container before. Next, we'll fill in our make method. If the key name exists on our static resolvers list, we're going to store the value to resolver, and then return the executed closure, which will invoke our resolver and return whatever is created inside of it. If it wasn't able to find a resolver for that key, we'll throw an exception since we don't want to add extra error handling around this. We'll send the message, no registered resolver for name in the IOC. Alright, cool, so that was nice and simple, but does it work? Well, let's find out. We'll open up example.php, we'll require the IOC class, and then we're going to write out IOC register, pass in the name logger, and then we'll just make an empty function. Then we'll cut our logger declaration and paste it inside of the closure and return it. Now we can delete our set logger line as well, and that'll do us in here for now. Next, let's open up our purchase manager file. We can delete no log entirely, then set logger, and now we can set this logger to be IOC make logger. This will resolve our logger straight from the IOC with what we've registered it with. Let's execute this in our example, and that looks like that still works well. But now let's try our tests, and we get IOC class not found. Of course, we have to update our test to require the IOC. So let's do that. We'll open up our test, require ioc.php, and then rerun. Now we can see our exception we defined in the IOC class where the resolver doesn't exist. Our test doesn't know about the example file, so we have to register a resolver in here too. In setup, we'll do IOC, register, logger, and then an empty function block like we did before. And now we're going to cut the mock that we defined in the test below and paste it in here and return it. Now we just need to delete the set logger line below, and now that we've defined what our logger is, when we rerun the test, our tests are green again. Now, just to demonstrate that this can go much further than what we've already done, let's enhance our IOC to be able to build an object with arguments that need passed in, so we can remove our product object's manual usage. We'll register a new resolver to the IOC, named product, and then the closure will accept two arguments like the products constructor does, name and price. Next, we'll say return new product, name, price. Now we'll hook up this functionality in the backend by editing our make method in the IOC, and now it's going to accept the second argument, params, which will be empty by default. Finally, we'll change the invocation of our resolver to use call user func array resolver params, so that we can pass the parameters in as an array. Okay, let's ensure this is still working as is by running our tests. Yep. There it is. So now let's remove the hard-coded usage of our product model. Inside of Purchase Manager, we'll change line 18 to use IOC make product rather than new product, and then we'll wrap the arguments in an array. Next, we'll head over to example.php and register the product again here. We'll leave our store array as is because we don't need to resolve it from the IOC like we did in the test, but we could do the same. Let's run our example to make sure everything's working, and it is. And this also proves that the resolution is working in Purchase Manager since purchase discounted product is returning the correct result. To recap what we just saw, we were able to invert control of our dependency resolution to our container, avoid manual injection, and then change the implementation of the logger between our tests and our example, demonstrating the way a container can give you extra flexibility with testing or various environments, even if the manual injection is unavailable. As mentioned, I'd recommend using a solid and battle-tested DI container in production. Laravel's offers a few advantages like automatic resolution of dependencies via type pinning, singleton support, and a few other things. I definitely recommend checking it out at least if you'd like to go the direction of a DI container. Next episode, we'll be covering the concept of tell, don't ask, which is also often referred to as the law of Demeter.